Anyway, I don't know if you had a specific question about hierarchy.
Well, so, I mean, I didn't see really guidance on the size of the input string that you could put into, you know, your 2,000 column, you know, 60,000 cell HTM. And, you know, but I can see that you're getting, you know, 2,000 bits out essentially with, because you're ordering together the predictive states and the active states, right?
Yeah, actually, it gets, all right, we can get into real detail, right? If I were to build, this was the start of the hierarchy. Hierarchies are obviously very, very important in all biological systems. We are not modeling hierarchy today. As we said, we were starting to do that with the vision stuff, and then it just got too computationally expensive. And then we decided, hey, look, we figured out that even a small region of the CLA actually can do something pretty useful.
Mm-hmm.
So they said, let's go with what we've got, you know, as opposed to fighting battles we can't win right now. So, so we're not doing anything hierarchy now. There's nothing in the code about this. There's people who want to do that. We want to do it too, but we're not doing that today. So, and therefore, since it hasn't been tested extensively, you know, it's unknown territory. We have concepts we think we know what it has to do in some ways, but it's definitely a researchy topic right now. But again, it's not a goal that the output has to be compressed. In our region, depending how you look at it, you're going from some smaller number of bits. The way we use it now might be just a few hundred bits, and the CLA actually has 64,000 cells. In theory, in one way of looking at it, you have a 64,000 bit output. Mm-hmm. Which is fine actually. It's not a problem right at that moment in time. But it's not like you have the goal is to make predictions and to be able to detect anomalies, and if you were to use it in a hierarchy, then eventually it has to coalesce, but at the moment it doesn't have to do that.
But isn't a hierarchy though just to simply, I mean, I could take two CLAs running with, you know, input set A and input set B, and then take the predictions out of those and run it into another one?
You could, but if you're doing something like vision, it's not like that. Vision, you can't just take different parts of the visual space and just parcelate it up. It's a one continuous process, right? So it's a continuous distribution across this. You can't take, you know, this little part of the visual space and just put them into separate CLAs. That won't work. It's a sheet. Just want to clarify about that.
But you could have lower level CLAs that understand, you know, basically
you
line
could. Actually, you could, but you wouldn't. It would be very hard to do that if you were saying, okay, this part of the visual space is continuous. So let's take something else. Like your ears and your eyes have separate hierarchies, and then they verge. They start merging like 4 layers up in the hierarchy, right? So they have their own little hierarchies, and then they start combining it. So I think as I wrote about intelligence, conceptually it's the same thing happening everywhere. But let's say we had one little region over here was looking at one thing, and we have another thing looking at something else over here. So this is some sensor A, and this is some sensor B. Right. It's not like part of the same sensory space. Right. Then in theory, you could build a small hierarchy. Okay. You could do that. That would be maybe a practical thing you could do today.
That's what I'm thinking. I'm not thinking vision. I'm thinking, okay.
Yes, that would be a good experiment to work with today. You could have essentially maybe 3 times the processing power needed that we run at the moment. Because, you know, let's say I have a 2,000 column CLA and another 2,000 column CLA, and I convert it into another 2,000 column CLA. So that's 3 times what we got to.
And how do you see prediction? Would it then be sent?
You know, I could speculate here. There's a ton of stuff we don't know about how the hierarchy works. And we do know that there's massive feedback. And I have a theory about what that's doing in terms of motor behavior, but I have a little bit less of a theory about what's going on in terms of prediction. And you know, I'd be just
feedback prediction.
Feedback prediction.
Yeah,
it would be. We sit around, just a couple of us with beer, we could talk about it. But with 2 cameras running, I think it's a little speculative to guess at that. We do know it's. We have some ideas about some of it, but it's a research topic. There's no question. By the way, one thing you should know that in like Envision, for example, we know that you can actually do an inference on an image in the brain where there's no time for feedback to play any role. So there's the time it takes for you to actually make the inference, there is not time for a single level of feedback going on. But that's probably not true for learning. During the learning process, you probably have to have that. You probably have to have the motor behavior, and all this other stuff. So, it probably requires all that.
Doug and I have been talking a lot about saving train networks. Maybe some kind of standard, I'm not even sure how.
Yeah,
There's a save method right now.
Yeah.
And then the model factory has a load from checkpoint. So you can do it now like, through the combination of pickling and manually writing the files from the C++ code.
and then settings, you would probably also pack those too along.
Yeah,
Let's
those are all
say I
separate.
want to give my train network to somebody with the settings and
Yeah.
Yeah.
say, here's my input sensors, I've done it for 2 months, it's really
Yeah.
smart.
Do we compress it too, I think? don't we?
I don't know.
Yeah, I mean, eventually you can choose that, but
Yeah.
that's
Oh,
how.
I thought we compressed it anyway.
Well, it's a sparse, we don't, it's a sparse representation that's saved, so it's, you know, compressed and that's.
I mean, there's some time to unpack it, right?
Yeah,
It's not just a number jump.
I don't know. But the nice thing is, because we're using this in our commercial product, it's fully backwards compatible. So you can serialize a model, save a model, send it to your friend, and if they're using a newer version of code, it'll still work.
okay. And we serialize the encoders as well, all the encoder parameters, all of that's.
Through the send method. So do you see that as maybe becoming a standard going forward if there's, or is this just kind of an ad hoc way to serialize right now?
No, I don't think what we're doing can be a standard because it's very Python specific.
Okay,
So I think you would really want a language independent mechanism. So we're relying on Pickle a lot, which is a
Right,
Python
right, that's
specific
what I thought, yeah.
serialization. So I really think you need something that's language independent. And, you know, if there was, you know, maybe we can participate in that or something, but we could switch to that, but,
I think there are people interested in doing that and they're on the forums, so maybe we can keep
yeah.
moving that forward, because I think one day it would be useful to have a standard, because you're gonna wanna share these train networks and interop, so.
That's a good point. I haven't really thought about that.
Well, I think you did, I think I heard you in a lecture talk about distributed hierarchy.
Well, that's not the same as sharing. That's not quite the same as sharing. I wasn't thinking about sharing at that time. I was thinking just that ultimately someday we'll have these hierarchies that the individual nodes don't have to be co-located and they
Yeah.
can be.
Could be a lot of
Yeah.
time invested in training.
Yeah,
That's true.
That's
Yeah.
true.
Yeah, like vision networks, for example,
Yeah.
it takes a
Right.
lot of time. And
Maybe it's hours now, it could be months.
Yeah.
Years.
the other
So-
thing we found is it's important to save is also the dynamic state, not just the static state. So this is sort of the cells which are in predictive state right now. And that's important if you want the system to be able to deserialize and pick up exactly where it left off.
Yeah, but if I was sharing it with someone saying, hey, this system has been learned on X, Y, and Z,
Right.
and you're gonna stick it in some new data stream, then you don't have to, they don't need to say that. But if you're just like stopping for the moment and wanna pick it up again later, then
Yeah.
you have to say this to